Section 5.6, this is a function I'm going to call even degrees. So the degrees are even in the numerator as they are in the denominator. So something a little interesting happens here. Let's go ahead and graph this. Let's start with, let's start with part one of graphing rational functions. So we're starting off with finding our vertical asymptote. So the vertical asymptote happens where our function is undefined. So we're going to set our denominator equal to 0. So our function is undefined when the denominator is equal to 0. So plus 4. Actually, I'm trying to save space here. So we have x equals 4 as our vertical asymptote. And let's graph this. All right, over here at x equals 1, 2, 3, 4. So vertical asymptote at x equals 4. And next, let's work on the horizontal asymptote. So horizontal asymptote is determined by our end behavior. And in a rational function, that's going to end up being y is equal to something. So in this case, y is going to be equal to the leading term in the numerator versus the leading term in the denominator. So that's going to be 2x over x, which the x's end up dividing out, leaving us with 2. So y equals 2 is our horizontal asymptote. So y equals 1, 2. That's our horizontal asymptote. So horizontal asymptote y equals 2. And part 3 is going to be our y-intercept. So y-intercept happens when x is equal to 0. So here we're going to evaluate our function at 0. So everywhere we see an x, we're plugging 0 in. So this part goes to 0, this part goes to 0. So we're left with a negative 1 over 4. So we have the point when x is 0, y is negative 1 over 4. So we'll say that this is 1, 1/4 is about here. Perfect. Next, we're going to look at when x is equal to 0. So our x-intercept, not when x is equal to 0, our x-intercept. So our x-intercept happens when our function is equal to 0. So we're going to set the function equal to 0. So 2x plus 1 over x minus 4 equals 0. So we're setting our function equal to 0, so multiplying both sides by the denominator. And that leaves us with 2x plus 1 is equal to, here we have x minus 4 times 0 is just going to be 0. 2x equals -1, and x equals a -1/2. So when x is -1/2, y is equal to 0. So this is 1. When x is -1/2, y is equal to 0. So we have that part there. Part 4, and now moving on to part 5. Part 5 is, does it cross our horizontal asymptote? So cross a horizontal asymptote. And what we do is we set our horizontal asymptote equal to our function. So here our horizontal asymptote was y equals 2. So y equals 2 is equal to the function itself, 2x plus 1 over x minus 4. And let's see what we end up getting. So multiply both sides by that denominator. So 2x minus 8 is equal to 2x plus 1. And now move all of our variables over to the left side. So anything with an x, we're moving it over to the left side. Minus 2x minus 2x. Those subtract out. Ooh, those subtract out as well. And we're left with negative 8 is equal to 1. Negative 8 does not equal 1. So here we're going to say that there's no solution. So not only is there no solution, this means that we don't cross our horizontal asymptote. So let's see where our graph is right now. So we know we're never ever going to cross our vertical asymptote here because that's where our function's undefined. In step number 5, we check to see if we were going to cross the horizontal asymptote. We never are. So our graph here has no other choice but to do something like this here, something like this up here. There's that. And because it's a function, we have to pass that vertical line test. So now we have this entire left side of the graph. So now we have to test the right side of the graph, see where we're at that part. So here, this is x equals 4. I'm going to go a little bit more to the right and say, evaluate the function at x equals 5 and see where we're at there. So for step number 6, our pick more points, we're going to evaluate our function at 5. So step 6, pick more points. So pick more points, we're evaluating our function at 5. So our function up here, we had 2x. Everywhere we see an x, we're going to type in 5 or plug in 5. And then 5 minus 4. So 5 times 2 is 10 plus 1 over 1. This is equal to 11 over 1, or just 11. So this tells us when x is 5, y is 11. So coming over here, when x is 5, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our graph is somewhere up here. We know it's never going to pass that vertical asymptote, so it's going to get really close to it but never touch it. Down this way, it gets really close to that horizontal asymptote without touching it. Because if it did touch at one point, then we know that it was going to happen right there in step number 6, but it didn't. And that's it. This is all I really need for the graphs. If you have any questions, please feel free to ask. Otherwise, bye.